Welcome back to this series on mastering coding patterns. In this series, we are learning coding patterns one by one so that we can ace our technical interviews. And today, what we are going to discuss? Today, we are going to discuss a very important question whose both naive approach as well as the efficient approach. Both approaches will follow sliding window approach, and that's why we will see both of them plus their code as well. So stay tuned. First of all, in this video, I am going to discuss the naive approach and will then code the naive approach. The naive approach itself is a very intuitive approach, so I thought like why not to share it with you as well. The code is very short, so it will help you write that down and solve this question very easily and in a very quick manner. You can use this naive approach if you are running short of time, so you can use it in your competitive coding competitions, or let's say if the interviewer is more interested in just the solution rather than the optimized solution. Second one, in the second thing, that in the second video, the second part of this series of this question, what I will do, I will share the efficient solution, the optimized one, so that you can learn, okay, what is the difference between the previous and this one, and how the optimized solution is better than the previous solution, despite both using sliding window approach. So let's jump towards the question. So what this question is about? So in this question, we have to find all anagrams in a string. Now, what is an anagram? So anagram simply means that if you have two strings, what you need to do, you have to compare one string, and if you have to see if by rearranging the alphabets in a given string, does they form the same string as the second one. If both of the strings can be made by rearranging the elements, then it means they are anagrams. If the string cannot be made, for example, if you take the AEB and here we have ABC, so these three alphabets cannot make ABC because there's E rather than C. So whether I arrange E by putting it here or I rearrange it by putting it here, it doesn't going to make any it is not going to make any difference for us, because AEB will never be ABC. So that's why AEB and ABC are not anagrams of each other. Now, in comparison with this example, we can see this one. So if you compare CBA and ABC, both of these strings are anagrams of each other. Why? Because if I rearrange just these three alphabets, just these three characters, what will happen? I will put A before, then B, and I will put C after B. So it will become ABC, and yes, they will match. So that's why these three CBA will form by rearranging these characters this ABC. Okay. So I hope now you got the idea what the anagram is. Now let's jump towards the question part. So in simple words, what this question is asking us, this question is asking that we have to return the first indices of those substrings of size k which can form a string P. That means that what we need to do, we have to find out the k which will be the size of P. So then we have to make substrings of size k, which is in this case, since ABC means 3, so the length is 3, and we have to make substrings of size 3. And then what we have to check, we need to check whether in this substring, if we rearrange these three characters, will they form P or not. If let's say they form, because in this case scenario we can see that yes, by rearranging CBA we can form ABC, right, by putting A before then B and putting C afterwards. So what we will do, we will simply update our result with the index. So what we will do, we will return the index 0 here, because yes, at the very 0th position of these three substrings, these three character strings, what we got an anagram by rearranging these three characters in that very first window of a substring. What we got an anagram, and that's why we updated our result with the 0 index. then we move forward, and when we will move forward we will see BAE. Now BAE will form ABC? No, they will never form ABC because there is E. So that's why what we will do, we will do nothing and we will just move ahead. Then our sliding window will move further. So here I have a window. So you can visualize it by this, that first we will start from here, CBA, then we will move ahead with BAE, then we will move ahead with AEB, then we will move ahead with EBA. Let me, yes, so then we will move ahead with BAB, then we will move ahead with ABA. So till now we are just moving. Why we are moving? Because no matter where we are standing, these three characters will never make ABC, and if we will move forward, these BAB will never make ABC, and then when we will move forward, ABA will never be equal to ABC because there is no C. Now move forward, and here we got BAC. Now let me quickly update here 0 because we found it here. Now we found BAC. Now ask this question, if we will rearrange these three characters, just these three characters in this video, will they form ABC? Yes, they will form ABC because I will put A here, I will put B at the second position, and C will remain at the third position. So ABC will be equal to ABC. Cool. Okay, so now we have got it here. So let's update our result with this position. So count, it's 0, 1, 2, 3, 4, 5 and 6. So at the sixth index we found that yes, this subarray, this substring is for is an anagram of this P. Awesome. So now what we will do, after updating our result, we will move further. So after updating our result array, we will move further and we will check the last subarray, and here we have ACD. So ACD will not become ABC, and that's why we will not add any further index to our result array, and this will be our final result. So how to code this solution via this sliding window approach. So let's jump towards the lead code question. So here we are, this is the question, find all anagrams in a string. The question number is 438 and the difficulty level is medium. But now you will see, just by following the same visualization and the same approach that we discussed right now, we will easily solve this question and in a very short code. So let's jump towards it. Okay, so first of all, how we are going to approach this question, right? We discuss here that okay, we will traverse this window from this position till the last position. But I have a question for you. How we are going to find out whether this ACD is equal to ABC? Okay, there should be a mechanism, right? So what we are going to do, we are going to basically sort our P. When we will sort our P, what will happen? Okay, yes, when we will sort our P, the P will remain ABC. But let's say if the P was CBA, so what it would have done, it would have made it ABC, so that we have a standard of comparison, right? So here we are basically updating our P with sorted. I am using the sorted function. Let me zoom it. Yes. And now what we are going to do, so in the sorted function, what I am using P. So what it will make, it will sort this P string. And then what we have to do, after sorting our P, we have to define our K. which will be our window size. So what is going to be our window size? Our window size is going to be the length of P. Why only the length of P? Because basically we need to compare this substring with the size of whatever P substring is. So we will compare with these three, that whether these first three are equal to this, then we will move ahead, then we will compare whether these three will are equal to these three or not. So that's how we will move our window. So that's why we are defining K as length of P. Now once we are done with this, then what we are going to do, we are going to initialize an empty array of result, because in this array we will basically add those indexes where what will happen, where the substring is an anagram of P. Perfect. So let's write the loop for I in range. Now this loop will help our window to move forward one by one. Okay, now till which point our window should move? Our window should move n minus k plus 1. Why only n minus k plus 1? Simply speaking, if you count the characters, it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So from 0 to 9, so it means there are 10 characters. 10 minus 3, because 3 characters of P, and we are making our window size 3, so it will give us these 7 characters. Good. 7 means if I put 7 in range and if I just leave this plus 1, what will happen? It will give us 6. And if you count 0, 1, 2, 3, 4, 5, 6. So from 6 to these 3, what will happen, that if I include 6th position, what will happen, that it will just remain till here. But what we want to include this A as well, because when we will jump over to this A, this 3 substring will form. So that's why our need is to be at A, and that's why we are adding 1. So what will happen, that from B our loop will move forward till A, and then it will stop, so that we can use this window of ACD to compare to this P. Okay, now let's press enter and now define our window string. So what is going to be our window string? This is S, and inside the S we will first write down I is this, and I have mentioned N here. I forgot to define N, so this is going to be N, the length of S. So in the total length, what we are doing, we are subtracting this K, these 3, I'm talking about the length. So this is 10 and this is 3, so 10 minus 3 is 7, and then plus 1 8. So what will happen, that Python will write down 8 here, but in Python, in the range function especially, the value is exclusive. Okay, the ending point is exclusive, so that's why Python will make a range of 0 to 7. Okay, so yeah, so this is going to be the range. Okay, so initially the I will be 0. So what we are saying from 0 till I plus k elements. K is 3, right? So 0 plus 3 is 3. So what we are doing, we are saying that give us elements from 0 till 3, but in slicing as well, what Python does, Python excludes the ending point. So what will happen, that we will get 0, 1 and 2. So from 0 till 2, so they will be like 3 characters, right? 3 characters. So these 3 characters are going to be compared and matched with these 3 characters, and then if by rearranging, which we will see how the logic is going to work, we will simply match whether these two strings are same or not. If these two strings are same, then we will simply update our result array, and if the strings will not be same, then what we will do, we will simply avoid and we will move forward. So our window will move forward. Okay, now enter. Now what we are going to do, we are saying if window string is equals p, then what you should do, you should update our res with I. Now Ali, there's this one thing that you are forgetting. I mean, just think, I'm asking you guys, just observe that we have sorted p, so p will eventually become abc. But what about window string? Window string will be cba, so when we are comparing them with equal, the answer will be false. Though by rearranging them, we can both will become equal. So what's the way that we can, is there any way in Python that we can rearrange this CPA in any form that it can be compared with this ABC? Yes, you have already did above that part. So what we will do, we will simply use a function sorted. So what it will do, it will simply rearrange CBA with it will simply rearrange CBA into ABC. So that's why when it will become ABC, it will be compared with this ABC and the result will be true. In this case of AEB, no matter what we use, it will only going to remain AEB, and that's why it will never become ABC, and that's why the answer will be false. So if, let's say, the answer of this condition is true, for example, if by rearranging CBA, if they become ABC, then what do? You update the result array with the index, because we have to eventually return all those indices where we are finding anagrams in S that are anagrams of P. Okay, and eventually what you have to do, you have to return res. Perfect. Now we are done with this code. Let's click on run, and our code got accepted. Let's submit this code. Wait for a while, and yes, our code got submitted. Okay, so as you can see that it took a little while in order to run through all the test cases. One of the reasons is that this approach is naive approach. Though the code is very intuitive, I personally like it, but this is naive approach. Why this is naive approach? Let's discuss this part. So what is the main issue? The main issue is that we are using this sorted, right? This sorted function. The problem with this sorted function is that in Python, the time complexity of sorted function is O of n log n. So that's why here the problem is that whenever we are traversing, every time we are like using this O of n log n time complexity, and that's why this solution is the naive approach, because this solution can be solved in O of log n, which we will see in the next video. But I hope you like this approach. This is a very easy approach and can be written in a very short code like this. So I hope like you get some benefit by learning this approach as well, because since it is short in code, so it is far easier to write in coding interviews, or let's say in competitive coding competitions where time is important than the optimization of solution. Once you are done with this naive approach, you can move towards the optimized part as well. And it is better that in your technical interviews, it is recommended that first you should discuss the naive approach. Try to if you have enough time, try to solve it by naive approach, and then explain the naive approach, and then discuss your optimized approach, and then refactor your code, update it, and then run it, so that your interviewer can know, yes, this guy knows both the naive approach as well as the optimized one. So this was the naive approach. In the next video, I'll discuss the optimized approach as well. So stay tuned, and I'll meet you in the next video. Take care. Bye.